Okay. Problem solving with primary trig ratios. I say problem solving, but I didn't write any of the wording down, so I just kind of made a visual. So you described to me there is a flagpole, which we have here, and there are two girls standing on the same side of the flagpole. The two girls are 50 meters apart. The heights of both the girls are 1.7 meters. They're the same height. The angle of elevation from the first girl to the top of the flagpole is 11 degrees, and the angle of elevation from the second girl top of the flagpole is 7 degrees. They want to know what the height of the flagpole is. Well, we're going to assume that this flagpole is 90 degrees. Okay, we need to make that. Yeah, we pretty much have to make this assumption. We're going to assume it's a 90 degrees, so it's standing straight up. Because we have that, this being 90 degrees. Oops. Since that's 90 degrees, and we have the angle of elevation here, and we have, oh, actually, sorry. When I was looking at this, I was thinking that this distance was 1.7, but it's not. Oh, okay, this is better. So we do need both girls' information here. Alright, I'm going to change the name of the video. But I said at the beginning it was primary trig ratios, but it's not. We definitely need to use our sine law, probably cosine law. Maybe, probably both in this situation. Okay, so these are their heights. So we actually don't have these distances here. But we do have the distance between the two girls, which is 50, which is one part of a triangle. So we know from here to here it is 50 meters. So this arm of the triangle is 50 meters. This angle is 7. We need 3 pieces of a triangle in order to apply our formulas to solve anything else. Right now we only have 2. But because the two girls' heights are the same, okay, that means this is a straight line, and a straight line is the same as something that's 180 degrees. So since this is 11 degrees, we can assume that the supplementary angle, the other half of the 180, we take 180, and we subtract our 11 degrees. That's going to give us 169 degrees. Yep, that's right. So this angle here is 169 degrees. And now from this triangle, from here to here. Oh, that's so good that straightens it for me. Oh, wow. That triangle, we now have 3 pieces. We have this angle, we have this angle, and we have our 50 meters. In fact, because we have 2 angles, we actually have 3 angles. So we might as well continue with it. This other angle is going to be 4 degrees. 7 plus 69 is going to be 76. And we need 4 more degrees to get to 180. So this little angle here is 4 degrees. So we have all the interior angles and we have this exterior angle. What's going to help us here? Well, I could find this really long angle of this triangle, but this side doesn't give me any more information about this little triangle, which is more important to us. So I'm actually going to find this side because it's adjoining the 2 triangles. That's going to be helpful to us. So we're going to call that our x value. So if that's our x value, what can we use? Well, can we use our cosine law? For cosine law, we would need to find an angle where we need all 3 sides. And we don't have the measurements of 3 sides. Sorry, we're not finding an angle, we're finding a side. We're going to need the opposite angle of that side and another side, but we only have one side, so we can't use our cosine law. Sine law, as long as we have an opposite angle and an opposite side, we can do that, which we do have. We have this angle here, which is opposite of this side, so we can put together one of the sine law ratios, which will help us find this, this side, which is opposite of this angle. So let's write our sine law out. Our sine law is sine A, side A, or reverse, you can flip these two. It's equal to sine B over B equals sine C over C. We can name the triangle ABC any way we want. It's not really important. We're going to call A this 50 meters in that 4 degrees. So this becomes sine of 4 degrees divided by 50 meters is equal to, and we're just going to call, for simplicity's sake, we'll call this side B. So side B is what we're trying to find, and the opposite angle is 7 degrees. So sine of 7 degrees divided by side B, or x in our case, is technically equal to sine of 169 degrees of side C. This one, kind of irrelevant. We don't need it, so we drop that off, and now we have a ratio. We have two equivalent ratios. So we can solve for our x. A quick way to do this, if we cross multiply, it gets rid of our fractions. So we have x multiplied by sine of 4 degrees is equal to 50 times sine of 7 degrees. And because we want to isolate for x, before I do anything to equate, I'm going to move this sine of 4 degrees to the other side. So it becomes divided by sine of 4 degrees. So before I even got to my calculator, I've already set up the entire equation, so I can technically punch it all in one shot here. It's going to be 50 times sine of 7 degrees divided by sine of 4 degrees. So we'll get our calculator out. Put our calculator here. Oh shoot, this one's not sometimes in radians. See if that takes. We'll see if this takes. Sometimes that doesn't take. Sine of 7 degrees. Actually, it's written the other way. Yeah, clear everything. 50 times sine of 7 degrees. We'll do this in our first shot. Is equal to 6.09. Does that make sense? Yeah, that's totally okay. And then I'm going to take my answer and I'm going to divide it by sine of 4 degrees. Okay. And we're left at 87.3. So x is equal to 87.3. I don't remember what unit values were. Meters, I think. Okay, 87.3. Let's take a look here. If this is 87.3 meters. Okay, so what we can do is a little bit of a reference. If we check opposite angles, because I'm not 100% sure this is the right answer, the opposite of our 4 degrees is about 50 meters, okay? This angle, opposite of this side, is 7 degrees, so it should be a bit bigger than 50 meters, which it is. It's a bit bigger, so it's realistic. Unless we made a calculating error, that's a realistic value there, so that's great. We've now got the hypotenuse of this triangle. We have an interior angle and another interior angle. This is where our primary trig ratio will come in. Now we can find this part of the flag, and then once we're done that, we'll have to add it to the heights of the girls, because technically we're taking everything from the tops of their heads. So we have a new internal angle here. Our internal triangle, we'll do it in blue. And I'll redraw it to make it a little simpler down there. 87.3 and 11. So our little triangle is hypotenuse was 87.3, and that angle, and this was 11 degrees, I believe. All right. So we're trying to find the side, h. We could use sine and cosine law. What was I calling before? This one? Yeah, sine law. But we can use a primary trig ratio, which is pretty quick in order to do this. So, of the angle we have, this is the opposite side, and this is the hypotenuse. Do you remember from SOHCAHTOA which you would use if you have the opposite and the hypotenuse?
Yeah.
What would we use? So yeah, we use our sine ratio for it. So sine of our angle here, which is 11 degrees, is equal to the opposite, which is our unknown. We'll call it h, the height, over our hypotenuse, which is 87.3. To isolate for h, we bring 87.3 up, so we do 87.3 times sine of 11. Our height is, let's bring out that lovely calculator we had again, 87. Actually, what's great about this calculator, this is even more accurate. I'm going to take the answer from before and multiply it by sine of 11. What do we get? 16.6667. Well, I'm going to say approximately 16.7, and it's in meters. 11 degrees, yeah, that's very possible, 16.7 meters. This is an over-exaggeration. 11 degrees is actually a very small angle, probably looks something like this, okay? And if we're trying to draw to scale, which makes sense I'm just always trying to reference old sides or other sides of triangles to get an idea if we're doing it right. This side ends up being really long in comparison to this side, which makes sense. If this is only 16, 87 is much, much longer. So our triangle is probably somewhat accurate. Okay, 16.7, but we still need to get the heights of the two girls. So we take our 16.7 and add. Don't forget we have the height of the girl here. Figure, which was 1.7 meters. So we're going to add 1.7 meters. And that's going to be 4, carry the 1, 6, 7, 8. So we're estimating the height of this flagpole to be approximately 18.4 meters.